We're going to start with triangle inequality theorem first. And the good thing about these is that they're very straightforward. It's not a lot of solving for x. It's more so using the theorem to make a prediction or to answer the question. So let's talk about what it says. It says the triangle inequality theorem right here says the sum of any two side lengths of a triangle must be greater than the length of the third side. So if you have your highlighter and you want to highlight on your notes, I would highlight the word sum. Remember what does sum mean? Means addition. Any two side lengths. So on a triangle, we have three sides. So any of the two sides have to be greater than the length of the third side. So what does that mean? And here is a formula for you. We have an example right here with this triangle. It says AB plus BC is greater than AC. I'm talking about right here. AB plus BC is greater than AC. And if you remember, this means that is a segment. Segment AB and segment BC together are greater than AC. So AB is right here. So that length is 6. So that means that 6 plus BC, what is BC? Right here. BC, which is 8, has to be greater than length AC, segment AC right there, which is 10. And we know that 6 plus 8 is 14. So 14 is definitely greater than 10. So that means that it works. Let's try the next one. So this one was good. BC plus AC. BC, so that's over here again. BC is 8. And AC, now we're doing the other side. 10. Okay, so that's 8 plus 10 has to be greater than the third side. What is the third side? Well, it's right here, 6. Is that greater than 6? What is 8 plus 10? 8 plus 10 is 18. That's greater than 6. Yes, we're good. So that one is good. And the last equation for this theorem is that AC, so now we're starting with this length, AC, which is 10. If you're kind of getting the idea. So now we're going to add 10 with AB, which is the 6 over here, has to be greater than 8, which is the third side. And 10 plus 6 is 16, which is definitely greater than 8. So all of these worked, which means that it does create a triangle. We do have a real triangle here. Believe it or not, there's some side lengths that will not work. And that's where we practice it here. So here I did create a shortcut just to make life easier, work smarter, not harder. The shortcut is so important. You might want to highlight it. Because instead of doing all of this math and all the math that we did here, all we have to do is add the shortest sides, the two shortest sides, and compare them to the third side. So if we take the shortest ones, the shortest side lengths, and compare them to the third one, that's all we got to do. So here's an example. I have the side lengths, and the question here is, can it form a triangle? It's right here on the side. Can these lengths form a triangle? Well, let's see. Number one is 16, 4, and 8. So if I add the shortest lengths, which is 4 and 8, is it greater than the third side? And here it's not. 4 plus 8 is 12, which is not greater than 16. It's actually less than 16. So no, these lengths cannot form a triangle. Let's do number 2 together. 3, 7, and 5. What are my two shortest lengths there in that list of numbers? The shortest lengths should be 3 and 5. So if you add those, are they greater than 7? 3 plus 5 is 8. 8 is greater than 7. So yes, these three lengths do form a triangle. Okay, number 3. 1 feet, 1 feet, and 3 feet. Okay, my shortest length is 1 and another 1. Are they greater than 3? What is 1 plus 1? 2. 2 is not greater than 3. 2 is less than 3. So these lengths do not form a triangle. Okay. I'm going to do, actually, no. You will do the rest, the 6 that are left, and then check your work with the answer key. Okay, let's move on to the next one, which is finding a range for the third side. Finding a range. Do you know what the word range means? Range is like a set of, like a beginning and an end. From here to here, this is my range. So what are we trying to do? We're finding a range for the third side of the triangle, which means that you're going to be given two of the links, and you're going to find the third one. You won't find it exactly unless it tells you to, but we just want to find a range. From what number to what number can the third side be? So here it says, let x be the length of the third side. And we're going to see that right now. So it says, when I give you 2 sides of a triangle, you can find a range of values for the third side by finding the difference means subtract, and the sum means add, of the 2 given sides and creating a compound inequality. If you don't know what that is, here's an example of a compound inequality, and this is exactly how we're going to set it up. So the question is, when I said this is how we set it up, I mean right here. So when you find the difference, it's going to be on the left, and the sum will be on the right. So it says, determine the range of possible lengths of the third side x. Okay, and they gave me 2 of the links. So number 10, it says 5 and 7. So 5 and 7. If I find the difference here on the left, 7 minus 5. 7 minus 5 is 2. That's where my range starts. It starts from 2. And then the other side is 7 plus 5, the sum, which is 12. So the range of my possible lengths is any number x, any length x, that is between the numbers 2 and 12. Okay, so it could be any of the numbers between 2 and 12. It could be 3, it could be 7, it could be 5. Any numbers between 2 and 12 can be the length of the third side of that triangle. Let me do one more with you so you can see how I can apply this with these numbers, 22 and 14. So 22 and 14, I'm going to start with the difference. So 22 minus 14. And then on the other side, we're going to do 22 plus 14. So this is you applying the theorem. 22 minus 14 is 8. And this is how we set up the compound inequality from least to greatest. Least to greatest, unless your signs are flipped the other way, but from least to greatest. And then 22 plus 14 is 36. So there is my range of values that the third side could be for this triangle. Okay, go ahead and try to complete the rest of the problems on this side of the page. So you're going to be working here and here. All right, and then watch the next video for the other side. Thank you.